Hey guys, welcome to your atomic weight notes. Atomic weight, or we also call that atomic mass. So let's talk about how we find an atomic mass or an atomic weight. Scientists needed a standard of measurement for measuring and calculating the mass of other atoms. In the modern system of atomic masses created in 1961, carbon-12 became the standard for atomic mass. Carbon-12 is assigned a mass of exactly 12 atomic mass units. Atomic mass units are the units you're going to use anytime you're calculating an atomic mass of any element or atoms out there. And atomic mass units we know correspond to the weight of one proton or one neutron, right? They each weigh one atomic mass unit. So carbon-12 was assigned a mass of exactly 12 atomic mass units, and all other atoms' masses are measured and calculated relative to this standard. To measure and compare masses of atoms, scientists use a method called mass spectrometry, and we're going to talk about that more in your mass spectrometry notes. But right now we're going to try and figure out how to find an average atomic mass for a particular sample. So remember, in an individual sample of an element, there may be several different isotopes. Remember, we talked about isotopes in class. Isotopes are generally the same atom. They have the same number of protons. They can have the same number of electrons, but they have differing numbers of neutrons, right? So when we have an atom that has a different number of isotopes, a different number of neutrons, right? Same number of protons, but different number of neutrons in that nucleus. We call those isotopes. Still the same atom, but they're isotopes of each other. In order to calculate an atomic weight for an element that scientists can use in lab calculations, an average atomic mass is calculated. An average atomic mass is going to take into account these different isotopes that might be present in an element. So here you can see my diagram. We have a picture or a diagram of one carbon atom. How do we know it's a carbon atom? Well, it has 6 protons. We can see it also has 6 neutrons in its nucleus. Those 6 protons and 6 neutrons make it a carbon-12 atom. And as we know, the mass of a carbon-12 atom is 12 atomic mass units. That's our standard of measurement. Now, in a standard carbon sample, we know that 98.89% of the atoms are carbon-12. We're going to take a look at that diagram in one moment. However, we can also have atoms that we refer to as carbon-13. Carbon-13, of course, it's still carbon. It's still going to have 6 protons. The protons can never change, but in that nucleus, instead of 6 neutrons, carbon-13 atoms have 7 neutrons, okay? So that's why we call them carbon-13. The mass of a carbon-13 atom, as measured with a mass spectrometer, is 13.0034 atomic mass units. So we've got a difference in mass here. And in a carbon sample, 1.11% of those atoms are carbon-13. So not very much, but a little bit. Now let's take a look at our sample of carbon here. We've got a sample of many carbon atoms. And as we know, the mass of our carbon-12 atoms in the sample are 12 atomic mass units. I want you to go ahead and pause the video and go ahead and color code all your carbon-12 atoms the same color. Don't cover up the carbon-12. Just give them a nice circle in the same color. Okay, so hopefully you've got all your carbon-12 atoms highlighted, and then we're going to do the same thing with our carbon-13 atoms. Remember, carbon-13 weighs 13.0034 atomic mass units as measured with a mass spectrometer, and in a carbon sample, much lower percentage. Go ahead and color code your carbon-13 atoms. Did you find them all? Just one, right? Representative of this whole sample of carbon Most of the atoms are carbon-12, but we do need to represent this carbon-13 atom in our average atomic mass as well. So let's talk about how we're going to do that. How do we calculate average atomic mass? Well, we have to take into account the amount, how many carbon-12 atoms we have versus how many carbon-13 atoms we have, and their different weights. So here's what we're going to do. We're going to go ahead and take the percentage of carbon-12 atoms. Now here I've changed my percentage into a decimal. I've just divided my percentage by 100 to get the decimal there. So I've got 0.9889 for the percentage or the abundance of carbon-12. How many carbon-12 atoms in my sample are going to be carbon-12? It's this number right here, 0.9889. And then I'm going to multiply that by the mass of all of those carbon-12 atoms. Then I'm going to do the same thing with my carbon-13 atoms. I'm going to take the percentage of the atoms and multiply them by the actual mass. And you can see again, I took my percentage, I divided by 100 to give me the decimal, 0.0111. That's how many carbon-13 atoms I can expect to find in a sample of carbon times their actual weight. And then when I multiply my two numbers and I add them together, my pink number and my green number together, I end up with an average atomic mass of 12.01 atomic mass units. So scientists use this average atomic mass as the atomic weight of carbon. Anytime we are trying to calculate a reaction or some sort of something to do with carbon atoms in it, we use this atomic weight. No single atom actually weighs 12.01. We know that, right? Our carbon-12 atoms weigh 12 AMU. Our carbon-13 atoms weigh 13.0034 AMU. But this is our average that we're going to use to simplify calculations and take into account that not all carbon atoms are carbon-12. This number, this average atomic mass, takes into account all the isotopes of carbon that we might find in nature and how many of them we find in nature. So this is the number we use. All right, we're going to do lots more practice in class. We'll see you there.